of functions. Now what we have is we have f of x and g of x. So f of x is equal to x squared plus 4. And g of x is equal to square root of x minus 4. All right? So now, again, what we're doing is this is telling me to plug g of x into f of x. So just like if I said f of negative 1, you guys would do negative 1 squared plus 4. Right? If I said f of x plus 1, you guys would plug in, like if I said, what is f of x plus 1? You guys would plug in x plus 1 squared plus 4. Right? Whatever you plug inside the parentheses, that's what you plug in for your input value. So if I say f of g of x, just follow the pattern. G of x squared plus 4. The nice thing here is we know what g of x is. G of x is square root of x minus 4 squared plus 4. And now when we look at this, the square root of x minus 4 squared is just going to give us x minus 4. But there is a restriction. And this is what I was talking about. Sorry, name? Name? Huh? Hannah. This is what I was talking about. If I asked you to find the domain here, it makes sense that this would be all real numbers, right? Yes? However, just because we simplified this, you have to bring back your original restraint of what you plugged in. So this doesn't have any restrictions on the domain. You have to find the domain of the composition, as well as make sure you know the domain of your input function. This function's domain is restricted from 4 to infinity. So guess what? F of g of x simplified is just x. However, the domain is taken from the original. The actual composition is only restricted from 4 to infinity. So we have to make sure we keep that original restriction. OK? So to give you guys a summary of what we were looking at,